All right, you all are welcome to JP Smart Solutions Limited, and we actually offer the following services. We have power system design, analysis, and protection, which you are currently here for. We also offer services such as engineering project development, procurement of technical equipment, trainings and certifications, and general technical services. So if you require any of these services, feel free to reach out to us via call or WhatsApp using these numbers, or you can simply send an email to us using this email. So without further ado, let's simply begin. This training is a training on advanced power system protection using Etap software. And my name is Ekwe Jesse. These are our contact details. You can reach out to us for inquiries, for questions on this training, or for general questions. So, in this course, we're going to be having the outline. Now, the first thing we are going to have is an introduction to electrical power system protection. We are also going to have introduction to protective relays. We are going to have the concept and design of an overcurrent protection scheme. We are going to have the configuration of a MICOM P122/123 relay. Then we have configuration of SEL 751 relay. We are going to have configuration of Siemens relay 7SJ804. We are going to have the concept and design of a differential protection scheme. Also, we are going to have the concept and design of a distance protection scheme. And lastly, we are going to talk about arc flash assessment and mitigation in electrical power systems. So let me explain in details. Let's go to our LinkedIn. Yeah. Okay, so if you're not in our LinkedIn group, you can just simply search for this on LinkedIn and join, or you can connect with me on LinkedIn, but preferably you join this. Preferably you join this group chat. Okay. So this is a detailed course outline of what we are going to be doing. Now, we have the model 1, which we earlier stated, for electrical power system protection. So we are going to be talking about the concept of power system protection. We are going to be talking about the essential qualities of a protective relay. We are going to talk about protection zones and protective schemes in a power system, just to give a proper foundation of what power system protection is all about. Then we jump straight into model 2, which is an introduction to protective relays, where we talk about the overview of protection relay types and functions. We are going to talk about the MyCom P122123 and SEL 751, overview and typical applications, and we are also going to discuss basic relay operating principles. Next, we move on to model 3. And in module 3, we are going to be discussing overcurrent protection scheme. So we start by the concept of an overcurrent protection scheme. Then we jump straight into hands-on exercise, because this is actually a very practical course. So we are going to be designing an overcurrent protection scheme for motors and cables using only circuit breakers. Then we go on to another hands-on exercise in which we are going to be designing an overcurrent protection scheme for motors, cables, and transformers. Now we are going to incorporate overcurrent relays, since we are talking about overcurrent protection. Then we are going to talk about relay settings calculation, which will involve relay coordination using overcurrent protection scheme. And once we are done with this, because we'll be talking about phase faults, we move into the final hands-on exercise for overcurrent protection scheme, which involves earth fault protection scheme design. So we are going to be protecting the system using overcurrent relays for phase faults and for earth faults. Now, once we are done designing this overcurrent protection scheme, we come over to module 4, where we have configuration of MyCom P122 123 relay, and we are going to be working with the softwares based on the data we have designed here. How do we actually impute this data on our protection? How do we impute the data we get from our design using Etap software on our relay? That is basically what we are going to be doing here. So we are going to be talking about the software tools. We are also going to talk about how to set up relay communication protocols. We are also going to be talking about input output configurations, and lastly, of course, it's a very practical course, so we'll be discussing hands-on exercise, how to create and upload a settings file. That is, once we've done this, how to use those data and actually upload it to a protective relay. That is what this is all about for MyCom relays. Then we move over to the configuration of STL751 relay. We talk about the overview of the relay. We talk about establishing communication with the relay, configuring protection elements for phase, ground fault, neutral, and overcurrent, logic editor and control schemes. Then we have definitely a hands-on exercise, which is how to upload protection settings to the relay. And similarly, we have the configuration of Siemens 7S J804 relay, and we consider an overview of DeepC software, which we'll be using for programming the relay. So, establishing communication with relay, configuring protection elements for phase, ground, neutral, and overcurrent, configuration matrix, input output masking, and then hands-on exercise. That is how to upload protection settings to this Siemens 7SJ804 relay. And not to worry, we are actually going to be providing all the softwares. We are going to be providing the software for this, and software for this. Also, we'll be providing the Etap software version 24 for those who register for this training, because of course this is a free training for day 1 and day 2, totally free but totally value packed. Now, once we are done with the configuration of these relays, we move on to module 7, which is differential protection scheme. And over here, we are going to discuss the concept of a differential protection scheme. We are going to have a hands-on exercise first to design this differential protection scheme for a transformer, and then another hands-on exercise to design a differential protection scheme for a bus bar. So once we are done with that, we move into module 8, which is the distance protection scheme. And in distance protection scheme, of course, we have to explain the concept of a distance protection scheme, and we'll be looking at 4-step distance protection. Now, we have 3-step distance protection and we have 4-step distance protection, but we are going to be covering the 4-step distance protection because the 4 steps is an extension of the 3 steps. So if you can actually design a 4-step distance protection scheme, then you can design a 3-step distance protection scheme. The difference between the both types, 3 steps and 4 steps, is that we have an additional step working in the reverse direction, which makes it 4 steps. So we are going to have a hands-on exercise, of course, to design a distance protection scheme for a 132 kV transmission line. Lastly, we talk about arc flash assessment and mitigation in electrical power systems. So we are going to be talking about the concept of an arc flash, concept of arc flash analysis, concept of arc flash mitigation, methods of arc flash mitigation. We are going to be talking about the standards which we use in arc flash, such as the IEEE 1584, such as the NFPA 70E, such as the OSHA standards, OSHA. So we are going to be explaining all these standards and how to apply them for your arc flash assessment. Then we are going to carry out the hands-on exercise, which is the arc flash assessment of a power system network, and then arc flash mitigation using current limiting reactors. So we are going to be mitigating the magnitude of arc flash in the power system. So this is actually a power-packed protection course for everyone in the power field. So primarily, what you need to attend this course, you need to be interested in power system design, analysis, and protection. Definitely, there must be an interest. Then you should have a good laptop for Etap software and other related softwares. You must have access to strong internet service provider. This training will be done via Google Meet as we are on this, and we have the training cost to be 200 USD. Note that all sessions are recorded and will be shared. And of course, as we mentioned, today's training is totally free. So you don't have to pay for this. So, since we are going to be using Etap software, we'll start by having an overview of Etap software. So, let's come over here. All right. Now, what is Etap software? Etap is actually an acronym, and this is an acronym for Electrical Transient Analyzer Program. Electrical Transient Analyzer Program. And primarily, Etap is an analytical engineering tool or software that helps us electrical engineers or students or technicians to design, simulate, and analyze the steady state and transient or dynamic state of a power system. Now, we can actually employ Etap in various sectors such as the transmission, distribution, industrial, and transportation. So for the purpose of this training, we are only looking at the protection aspect. We are looking at designing protection schemes for our power system. So we have various capabilities for Etap software. Etap has a lot of things it can handle. The first is creating a digital twin of a power system. Of course, before analyzing your system, you have to create a digital twin. This is simply saying modeling your power system digitally. So creating your one-line diagram or your single line diagram, Etap has that function. Next, Etap can carry out a power flow analysis, also known as a load flow analysis. This software is also equipped with the capacity to carry out a detailed short circuit analysis. Also, arc flash analysis, which we are going to be carrying out in this training. Next, transient stability analysis. We have optimal capacitor placements for reactive power compensation. We have protective device design and coordination, which is also what we are looking at in this training. We also have reliability assessment and contingency analysis. Now, we can also carry out motor starting analysis in this software, but it is not limited to that. We can still carry out intelligent load shedding and much more using this software. So, for the benefit of joining the software today, we are going to be exploring the first capability, which is creating a digital twin of a power system. So I'll be switching to Etap software and just showing a few basics on how to model a system, because before we can design our protection scheme, we must first of all model this system. We must create a digital twin of the power system before we can talk about designing the protection scheme. So I'll be switching to Etap software now. All right, this is Etap software. I have created a file just for purpose of illustration. I am using Etap version 24.0.1, which will be shared to everyone who registers for the training. So we'll be giving you this software so you can actually practice along. And now, once you create a file on this software, this is the interface you see. We have over here what we call modes in Etap software. We have the edit mode, we have the power flow group, we have the short circuit group, we have the protection group, which we are going to be maximizing in this training. So primarily for this training, we will be focused on the edit mode, the short circuit group, and the protection group. So edit mode, load flow, short circuit, and protection. This is what we are going to be considering in this training. And at the end of the training, the last module is the arc flash group. So we are taking 1, 2, 3, 4, 5 for the purpose of this training, for a detailed training on power system protection. So firstly, we have the edit mode. Now for the edit mode, it gives us access to this over here, which are our equipment. We have our AC equipment, we have the bus bar, we have the transformers, we have the transmission lines, we even have our power grid, we have our induction motors, we have synchronous motors, we have our long load and static load, our capacitors. These are our protection equipment such as our current transformer. We also have the potential transformer, we have our relays. We can scroll down. You can see our circuit breakers and our relays. This is a high voltage circuit breaker. This is a low voltage circuit breaker. These are our protective relays. So these are all AC equipment. If we scroll down, we can also see we have converters and DC equipment below. So we can actually carry out analysis on AC equipment and DC equipment, AC power systems and DC power systems using Etap software. Now, this is our workspace, and we need to create a digital twin of a power system. So let's just go randomly. All right, let's have a power grid. Primarily, we have two approaches we can utilize. The first is the manual, as I usually say, and the second is more of an automated way of creating your one-line diagram or your single line diagram. This manual way is, as you saw me do, I clicked on the equipment and brought it out here. This is a power grid. Let's assume I want to connect it to a bus bar. I locate a bus bar. Now Etap is quite wonderful because it gives room for professional engineers and even students to easily learn. Now assuming you are not familiar with the interface, or you are not familiar with standard symbols, you simply need to take your cursor over to the symbol, hover around, and you will see the name of the equipment. You see the name of the equipment. So assuming I'm looking for a bus bar and I really do not know the location or the symbol of this bus bar, all I need to do is hover around until I see this is a node and I see a bus. Okay, this one is actually written bus. So if you click on it, you can see it follows me everywhere I go until I come over here on my workspace. I click on the workspace and I've dropped the bus bar. Now, how do I connect the power grid to the bus bar? It's quite simple. We hover our cursor around the power grid until we are able to find this pink dot. Now, this is our connection pin. Once I click on this pink dot, a connection line follows me wherever I go. And I can take it over here. And you can see, if I wish to connect it to the bus bar also turns pink by bringing the connection pin towards it, showing it is suitable for connection. It is compatible. So if I click on it, we have it connected. Next, let's assume I want to introduce a transformer at this point, a two-winding transformer. As you can see, the name has popped up. So I can click on this, come over to the workspace, and you can see transformer is following me, and I click, I drop, and we can see our connection pin, it's pink for the primary of the transformer connecting to the bus bar. The bus bar turns pink, I connect, and then let's say we have another bus bar. It's quite simple, just click and drag, plug and play, a very simple software. We click this and we drop. So we've connected this. Now let's say we wish to connect a cable or three cables to this bus bar. Let's say we wish to connect three cables to this bus bar. Now the first way is that we need to bring out these cables. Now we can do it manually. We can bring out one, come over here, let's say somewhere here, and we drop. We come over here again, repeat the cycle, click on this, bring one and drop. Come, but alternatively, we can just double click on the cable, and once we double click, we come over here, we drop the second, we come over here, we drop the third. So we can drop as many as we want, depending on your preference. Now once we are done dropping, since we need three, we can either press escape key or come over here, which we have the selection pointer. So we click on this and we are no longer with the cable. Now the question is, how do we connect all three cables to this bus bar? Seeing we can only do this, okay, let's say we connect this guy here and we can move him over here. Okay, let's say we connect this guy here. We can also connect this guy over here and connect this guy over here. Looks a bit presentable, a bit okay. Alternatively, you can delete this connection line and delete this connection line. We can expand the length of this bus bar. Now, to expand the length of this bus bar, we simply need to click on the bus bar. Now, the bus bar, we've selected it, we've highlighted it, that is why it is red. To expand the length, we simply take our cursor to the edge of this bus bar, and we can see, taking it to the edge, the cursor is changing to a two-edged arrow. We click and we drag. We can see an extension line. And see, we can extend to as long as we want. Let's keep it at this point. And we can see we've extended this left-hand side of the bus bar. We can repeat the same exercise for the right-hand side. Click two-edged arrow and drag. We can see we've expanded the bus bar, and we can simply connect this. We connect this. Okay. So we've been able to connect our cables. Now, assuming we want, okay, let's use individual buses. Let's have three buses here, and we link them with bus couplers. Yeah. So we double click on the bus because we don't want to be going one by one, and we drop one bus, another bus, and another bus. And we click on our pointer, and we connect each of them. Okay, let's move this a little bit. We connect each of them. You can see we are gradually building our power system. We are gradually building. And now we want, probably we can have, okay, let's just wrap it up at this point. Let's put loads. We have loads, lump loads. Let's keep it simple, simple system. And we connect this. Okay, then we can expand the buses. And we can actually link them using bus couplers. So let's assume it's high voltage. Keep one here and one here. Now, to rotate this, we simply select the equipment and click on letter arrow. You can see arrow for rotate, and we've rotated this. We link this. We link this. We repeat the exercise for this. We link this, and we link this. And we want to change the position of this to normally opened instead of a normally closed breaker. So we double click on it. Once we double click on it, we can see service, in service or out of service. Then for the position, normally closed or normally open. So if you click on open, we click OK, the circuit breaker opens. Alternatively, we can highlight the breaker and press letter T, T for toggle, and we've been able to open the circuit breaker. So with this, we are gradually modeling. We can actually model a much more larger system, but let's leave it at this. Let me also illustrate the second approach. Let me move this over here. Okay, now for the second approach, we are going to be using the automated approach, which is the use of the one line auto build. Now, when we say auto build, we don't actually mean that you just tell the software, oh, I need a power grid connected to a bus bar, then a transformer to another bus bar, 3 cables to a bus bar, attach lump rods on each cable. No, it's just an easier approach. For example, if I enable this and I come over here to replicate this system, I come over here and I have the power grid. You can see once I click on the power grid, some items are grayed out. They are grayed out. Now, the fact that they are grayed out means that they cannot be directly connected to the power grid. For example, we cannot directly connect a generator to this power grid. There must be a means of connection. There must be something, preferably a bus bar in between. But we can connect a bus. So this is one of the benefits of the auto build. It shows you equipments that are compatible and equipments that are not compatible. So let's say we want to connect a bus. Now the traditional approach which we used previously was to click, come over here and drop, then connect. But this time around, using this auto build, we just click on the bus and it is automatically connected. Oh, we need a transformer, we just click on the transformer and it is automatically connected. Okay, we want this transformer connected to another bus bar, we just click on it and it is automatically connected. Now this actually saves time, increases efficiency by telling you equipment that are compatible to connect and equipment that are not compatible for connection directly. Now, assuming we want similar scenarios, this is where it gets tricky. Yes, you still have to get your hands dirty because the auto build will not automatically expand your bus bar for you. So you come by yourself and you expand your bus bar. So we need cables. We can also double click and drop your cables. One, yes. In the auto build, you do not have the feature of double clicking, so you turn off the auto build for this double clicking feature, where you can drop as many as you wish, and then we can connect this to the bus bar. And we want each of them to be connected to a bus bar, so we can just put a bus and a lump load, a bus and a lump load. Over here we come and we put a bus and a lump load. So we've been able to replicate the system. Here we can add our bus couplers over here to complete it. We can just zoom to fit page. Okay. So we have this. Now I can just remove this. Let me delete this. Another feature. Okay, I just deleted that. However, if I actually need to get data from that, we come over here we have what we call the system dumpster. So I can simply click on this to restore. It's more of like your recycle bin in your PC. When you delete something, it goes to the recycle bin. It's not permanently deleted. You can always recover from the recycle bin. Similarly, Etap has such feature. If I click over here, you can see this is the system I just deleted. So to permanently delete, I have to come over here and delete. And I can close this, and we are back to this guy over here. Now, one more feature. Assuming I want to expand the system, okay, let's make it look much more better. I can come over here, select all this, and over here we see templates, add to OLV template. So if I click on this, let's call it templates number 1, and I click save. Following one line view template file was generated successfully, and then I come over here. Here, get template. Assuming I want to create a replica of this, if I click on get template, it shows me, okay, which one do you want? Okay, we just created one, template number 1, and I click OK. You can see an exact replica of the system has been created. So I can bring this over here, and then I can expand this bus bar, connect this transformer over here. You can bring the power grid to the central source. Okay. So now we've been able to create a bigger system. We are making the system much more complex. We can introduce an alternative source of power on this bus bar. We can put a bus coupler here just for expanding. Now, lastly, when you use this template feature, observe if I click on this transformer, I'm selecting the entire system. But if I come over here, I click on this transformer, I'm only selecting the transformer. The reason for this is that we grouped the equipment to put them as a template. To actually neutralize this effect, we simply click on one of the equipment, be it the transformer, be it the cable, or whatever, and we right click. See this option where we have group, we uncheck it. And we can see we have individual settings, individual equipment. So basically, that is how we play around modeling our single line diagrams. There are other features which we can actually work on, but at this point, I'm going to be opening room for questions. So if you have any questions, just I'm going to unmute microphones. Any questions so far? Okay, let me unmute your microphone. You can turn on your microphone and ask a question. Ashley.
Hello?
Yes, we can hear you. We can hear you.
Okay. Now, if you see this model now, right? You see where you indicate cables, right? Are you getting me?
Yes, we can hear you.
Okay. Now, if you see this diagram now, this your model, right?
Ashley.
You see where we indicate cables. Now,
Let me check if extension there.
from the
Laptop on what?
power grid to the transformer, your drawing is not showing. I'm not seeing your this thing again, your screen. Hello?
Okay.
Okay. Now, from the power grid to the bus bar, what exactly do we use to connect it? Is it not cable? And also from those bus bars to the transformer, why is it that they are not shown as cables? And then these ones under are shown as cables.
Okay, to respond to that, we are the ones designing this. You can put the cables there. I was just doing this for a purpose of illustration to show how to connect equipment together. Before the bus bar, at this point, let me move to it. At this point, you can put a cable. This is just a connection. This is a three-phase. It's also indicating a connection, a three-phase connection. So at this
Mm.
point, we can put a cable. You can put a cable before the transformer and after the transformer. You can put a cable anywhere you wish to. This line now is indicating a three-phase connection.
Yeah.
So it still indicates the same thing.
Okay, because why I ask the question is this, eh?
Okay?
Hello?
Yes, I can hear you.
Why I ask the question is because in the after the course of doing that, you have to also know the size of cable we are going to use in such connections.
Yes, yes, definitely. Cable sizing is crucial.
Okay.
Okay. Any other question? To check this. Let me see. Okay, checking the chart. You're new to it. Okay, yes, you can do copy and paste in the circuit rather than using template option. Yes, you can. So now the query is okay. The recording will be shared. Yes, definitely. Nobody had. There was a station in this house now. Yes, Shadrach, you have your hand up. You can ask your question. Ask your question.
Okay, good evening, sir. Um, my question goes thus for I believe it's not everyone here that has a concrete knowledge in the electrical power and design. So I don't know if there's any material that can better illustrate the usage of this software for easy understanding. Thank you, sir.
Okay, so for those who are not quite familiar with the Etap software, you can actually feel free to contact us, and we have trainings from basic to intermediate, from basic to professional, depending on the package you actually want. So you can feel free to contact us at any point in time, and definitely we'll train you. Okay.
Okay, sorry. You said you were going to share the record for today's class. I don't know on what platform.
All right. The recordings will be shared via email. So we'll be sending you the recording via email. I will upload it to our YouTube channel, which you can also check for other videos. And then I'll share the link to everyone who registered via their email, so you can easily access it.
Thank you, sir.
All right. Any other question? All right. If there's no any question at this point, tomorrow's session we are actually going to be talking about the relay configuration. This was an introduction to the Etap software. In the session tomorrow, we are going to be talking about the introduction to our protective relay softwares, and we'll be sharing the softwares, most of them free. Definitely, we want everyone to become experts in using it. So we'll be sharing the relay softwares free for the Nikon, the Siemens, the SEL, free for everyone. So try as much as possible not to miss that session. Now, any question before we proceed using the Etap software? Okay, in the absence of questions, I'll be switching back to Etap software. So we have this system over here, and someone asked, can we do copy and paste instead of the actual add to template, retrieve from template? The reason I recommend this add to template feature is this. Doing the add to template feature, you can put it on any workspace. Meaning that if I should open a new project, meaning I close this and I'm working on a new project and I need a similar topology of the network, I can always add it. But for copy and paste, of course, we can use our Control C to copy, and we can come somewhere here. Let's just say Control V. You can see. Let me move. You can see we have this system over here, the same system. So yes, it works. You can still expand this over here, and we connect this. So it works. But now this is limited to these projects we are working on. But using the template feature, it is not limited. One additional feature which we maximize is known as the composite network. There are many hidden features on Etap software. You just need to know what you're doing. Now, when it comes to the composite network, we also have features like the remote connectors and all that. But let me explain the composite network. Now, as I mentioned earlier, if you hover your cursor, you will see the name of the equipment. Now we have what we call a composite network here. Basically, a composite network is a network of a network. It is a network of a network. So if we click on this and we bring it over here, okay, let's say we keep it here. We have multiple connection pins. Let's say we connect one of it to this bus bar, bus 2-1. Take note of the name of the bus bar, bus 2-1. Now once we connect it here, we can come over here. If we open the composite network, that is double clicking on this, we are opening it, we can see bus 2-1. So basically, as we explained, it is a network of a network. So it is giving us more room to design a whole lot. Okay, let's have this system here again, and let's say we have another of the same system here, and let's have the same system. So we can have all this inside the composite network. Now how do we then connect this to all this? Now we are going to need a central bus bar for this. So let's say we come over here and we put a bus bar. We can expand the bus bar as usual. And we connect these transformers. And then let's just have a cable over here. Connect to this. And we can move this guy. It's usually very small to move. Okay. We can move this over here and we connect the cable to it. Now, everything here is a subsection of this bus 2-1. So that is why we said it is a network of a network. How do we return to our original network? We come over here. You can see current composite network 1, which we just created. If we click on this, we come back to OLV1. This is our main network. So everything we just designed is inside here. So it is a very usable feature, especially when you have a complex power system. Now we can also, of course, connect this point to bus 6. So it means we are having two sources inside the network. Now if we open the network again, we can see that we've gotten bus 6 over here. So we can use another cable saying, okay, in case we want the two to be linked together, we connect this and we connect this. Okay, so far, any question? Any questions so far? We've come to the end of today's training. Okay, in the absence of questions, just a quick review. In tomorrow's training, we are actually going to be looking at this. We are going to be looking at the introduction to protective relays, where we'll be sharing the softwares for these relay configurations. Totally free, of course, as we mentioned. Everything we said is going to be free, is going to be free. So we are going to be sharing this totally free. The link for tomorrow's session will be sent to your emails. For those who did not actually register for this training through the Google Meet we shared earlier, if you just joined using the invite link, then simply send an email to us or contact us directly. This is my LinkedIn handle, or come over to our group JP Smart Solutions, comment on this post and drop your email. Preferably everyone should drop their email as a comment on this post so we can send the recording using that. And now, as we mentioned, you'll be getting the protective relay softwares. We'll be showing you how to use these protective relay softwares. So tomorrow's session will actually be very much fun. Do well to join in, and thank you all so much for joining today's session. See you in tomorrow's session. No, your emails should not be sent on the Google Meet. It should be sent on LinkedIn. Come over to LinkedIn. This is our group chat on LinkedIn. This is the name of our group chat, JP Smart Solutions Limited. So all you need to do is come over to this post on the training, which is this. Come over here and drop a comment as your email. Drop your email as a comment over here, which will share the records. So, in the absence of further questions, thank you all so much for joining JP Smart Solutions, and we'll see you in